Okay, in this lecture, I will show you that how you will use Microsoft Excel in order to solve one-way ANOVA questions. So I'm just going to the same question which I already solved in my previous lecture, that how we will conduct in one-way ANOVA while using solving it manually. So you know that in this question that we have 3 samples, and in each sample the observation was 4. So I have already solved this in my previous lecture. In the recorded lecture, I show you that should we need to accept the null hypothesis or not. All the mean of all these samples are same or not same. So from here we know this, we know it from the critical region. So I already show you in that lecture that how you will calculate the F critical value from the F table, F statistic table, so which was 4.25, and we have already calculated in the ANOVA table that our F calculated value was 2.80. So 2.80 was lying in the accepted region, so that is why we accept our null hypothesis. Now I am going to show you that how we will solve the same question by using Microsoft Excel. So you can see this is the same question. We have 3 sample data, 3 type of groups. The sample 1, sample 2 and sample 3. In the first sample we have 4 observations, in the second sample we have 4 observations, in the third sample we have 4 observations. So before going to use Excel solver, you need to check it. You need to click file, you need to check the option. Okay, in the option you need to click this add-in. Okay, when you click this add-in, go to the Excel add-in. So when you go to the Excel add-in, you make sure that you click this check box. So I mean check this box. Okay, if you not check it, you will not get the analysis tool pack. So when you check it, then you need to click this OK, and when you click this OK, go to the data. When you click the data, you will go to the data analysis. In the data analysis, there are ANOVA, 2-factor ANOVA, with replication, without replication, correlation, covariance, difference, statistical, moving average, related to the T statistic, related to the Z statistic, but we are only interested in the single factor. So one-way ANOVA is also called single factor analysis. So you need to click this and click OK. When you click this OK, now they are asking you that what is your input range. So I want to select this 4 range. If the sample, if the observation sample is not equal, you also need to check to select all those areas, because Excel will calculate it for you if the number of observation in each sample are same or is it different. Let's suppose this is 4 or if it is 3, so you need to select this whole. If there is nothing, so Excel will already compare, Excel will also already calculate this. So we select this. Now we also need to check this click, because we also include the title of the table, the title of the column. So I mean this is sample 1, sample 2, sample 3. So I also click this. Okay, you want to conduct a level of analysis, level of significance, you want to keep it 0.05 or more than 0.05 or less than 0.05. So you need to choose this. Then output option, you want to put the result on the same sheet or you want to use another sheet. So new worksheet. I am clicking this or new worksheet. So okay, so you can see from this, you can see ANOVA single factor. So this is the average, these are the variances, and this is my ANOVA table which we have already calculated manually. So this is between group. As you people know what is between group. Between these 3 groups, the sum of square is, so this is the treatment sum of square. This is my treatment sum of square, and this is error sum of square. Error sum of square is also called within group, which is 876.2. And between groups, so how many groups we have? How many samples? We have 3. So 3 minus 1. So you can also write this 3 minus 1. So 3 minus 1 is 2. Okay. So this you can write this 3 minus 1, because this is C minus 1, and this one is N minus C. So N is 12. So 12 minus 3 is 12 minus 3 is 9. And mean square, so how you will calculate average of square? 546 divided by 2, so you will get 273. 876.25 divided by 9, you will get 97. So this is our F calculated value, and Excel already calculate this for you. So as you people know, when P is greater than level of significance, so what we do? Accept H0. If P is greater than, less than alpha, reject, accept H 1. So now in this case our p-value is 0.1, which is much higher than the level of significance. This value is much higher than 0.05. This is our level of significance. So what should we need to do? We should need to accept, and manually I already show you, because Excel already calculated this value for you. Excel already calculated this value for you, because for F 0.05 and 29, so I already show you that how you will use table. So that from the table we already calculate this 4.25. So this is our accepted region. So basically our F calculated value lying at this, because this is 2.80. So that is why we accept our null hypothesis that all the mean are of this data of this experiment, all the mean of these sample are equal. So we will accept null hypothesis. So from this p-value you can also accept a hypothesis, and from this F critical value you can also accept or reject. So this is the simple way in order to construct an ANOVA. I hope you understand, and the same result we have already calculated in the manual way in my previous lecture. Thank you so much.